Well, thank you to everyone for taking time out of your day to learn a little bit about iTree, and thank you to Justin and Danielle from the state of Vermont for putting this all together and for inviting me to talk about iTree a bit. So today what I thought we would do is kind of break up the session into different sections. So we have, well, roughly an hour and a half, so that's a long time to be talking about software. So I'll give you a little bit of background on iTree, and then we'll talk about the ground-based assessment tools, namely iTree Streets, iTree Eco. I'd like to talk a little bit about iTree Pest detection module, and then we'll take a break there and try to catch up on some questions and so forth, and then move into some of the other tools, the online tools, and some of the tools that are working more with aerial assessments. And then while we're doing this, I'll also try to, since I imagine there's a range of folks, some who have maybe used iTree or investigated, some who never have, and I'll try to give you some of the strategies for implementation that might kind of help you consider how to actually get your foot through the door, where to start, how these tools might be used. It's a lot to digest. And so iTree is essentially a software suite, and it was first introduced in 2006 at the International Society of Arboriculture Conference in Minnesota. And I wasn't part of the iTree team back then. I was actually working in county government, managing parks and forest preserves and so forth, golf courses. And so it was actually quite interesting to see that tool as it was first presented and how it has evolved. I've been working with the iTree tools roughly for about 5 years now. And so it was developed, and the research goes back way beyond 2006, back into the 90s. So the Forest Service was conducting a number of research projects going on at Syracuse and Davis, California, and University of Massachusetts. And somebody had the insight to say, hey, let's bring all these tools and bring them under one umbrella where we can manage them and then actually turn them into a suite of tools that we could then make accessible to communities, nonprofits, individuals, and then also provide support for these and try to help people advance urban forests and community tree management. And so the tools are free, so it's public domain software. I'm not sure why this keeps bouncing up here. It's public domain software, and we do provide technical support for it, and that's primarily what I do a lot of, is the day-to-day support, managing the aspects of helping folks get through the various hurdles of using the iTree tools. And then it's also very dynamic in terms that it's constantly being improved. So we don't have a whole big staff. We're not Google or Adobe or so forth. It's a handful of people. We probably have enough folks to put together maybe a baseball team if we were all in one room. And we all do other tasks on top of iTree too. And so we are constantly juggling a lot of things, but we're trying to constantly improve things. We rely heavily on user feedback to give us information and what are the needs in communities and so forth. Well, that's a little bit of the background. And right now it's cooperatively managed. Those organizations at the bottom, the U.S. Forest Service, Davey Tree, the Arbor Day Foundation, Society of Municipal Arborists, the ISA, and more recently Casey Trees. So there are individuals from each one of those organizations that guide the overall direction. And then there's a number of us who work in the background on various tasks related to iTree. And so the basic premise behind iTree is that it is a benefit-based assessment tool. So if you are not familiar with assessment tools, I try to make a distinction between inventory and assessment tools. A typical tree inventory tool might provide you with good structural information. What is the composition of my urban forest, the species, the age, the condition, and so forth. Where iTree differs, it allows you to take that information and move that information into a model to allow you to actually determine what are those ecosystem services that that resource is providing. And so it allows you then to have a more comprehensive value of that resource, and that essentially allows you to be more strategic in your management and your advocacy for policy and so forth. So I look at it in terms of a progression. So many people have inventories and are able to bring that information into iTree and then get a bigger picture of what are those values that trees are providing, and it allows them to be more effective. So that's the basic idea. And since 2006, we've seen a number of communities use this information to demonstrate tree value. So from simple things like developing tree tags for Arbor Day functions, such as the one on the left here from the Morton Arboretum, to really more comprehensive assessments, which we've seen now more recently from Kim Miller and some of her teammates at Wisconsin DNR, where they've done assessments using iTree streets on 19 different communities, and then also use iTree Canopy, and had some really effective media events to try to emphasize, the value of these trees in those communities. So it's been really effective, and that's been fantastic to see and help move those projects along. And then more recently, with some of the impacts of emerald ash borer and things that are actually threats to the urban and community forests, people have now started finding different ways of adapting the tools. So not only to show what might be gained, but what might be lost in terms of canopy impacts from destructive pests like emerald ash borer. So this is something that David Sibier from the city of Milwaukee and his team pulled together. A lot of folks might know what is the percentage of trees that might be lost, but what are those functional impacts? And then using that information to help advocate and develop a policy of how to actually deal with these destructive pests. So in the city of Milwaukee's case, they decided that it was to their advantage to use a more integrated approach, and they're treating some of their ash trees while removing others, and over time they'll probably adapt as needed and remove eventually all these trees. So it's not something for perpetuity, but this was something that was really effective in helping them make the decision and then advocate for the funds necessary to actually complete this project. And you can see there, that's, you're pretty effective when you can get your mayor to come out and participate in a media event promoting what you're actually doing. And so the idea is, being effective is not just taking that data, but actually turning that into some type of action. And that's not always as easy as just producing the data. I know many people who go through the process and use iTree, develop a report and so forth, and it pretty much sits on a shelf. But then there are others who are able to take that, make the connections, find out what are those issues that are most concerned in my community, and try to develop policies to then see effective change. That's not always as easy to do. But a number of communities, people like Gene Hyde in Chattanooga, Danielle Crumrine from Trees Pittsburgh, have really done some amazing work with just taking data and actually turning it into policy and plans and advancing urban and community forestry. And it's important to recognize that there certainly is no easy path. There are a number of challenges and threats that are still out there. And it's kind of interesting when you think back that iTree was first made available in 2006, and the economy tanked in 2008, but yet there's still a lot of folks who have been able to do a lot of good during that time in some really challenging circumstances that they have to deal with. So yeah, there's storms, there's political implications, there's diminishing budgets, diminishing manpower. All that is still on the horizon, and a lot of folks are trying to do a lot more with less. And so we certainly recognize that that makes things harder, and we're trying to find ways that we can adapt our tools to make them more accessible for different audiences too. And so the idea, we feel that iTree has been really effective and can still be effective in terms of building bridges, trying to find ways that we can connect community forests with some of these other areas, whether it be green infrastructure, which Justin is working on for the state of Vermont. Other folks might be interested in air quality initiatives, stormwater. There are a number, and I can't even fit all the possibilities on here, from wood utilization and so forth, where there are a number of different ways that we can build bridges with urban forestry. And we think iTree is a good conduit for helping us advance that. So this is what we have on the table for our discussion today. So right now, iTree version 5 includes 9 different tools, applications, or utilities. You might hear me use some of those words today. And I'm not going to go into depth on every single one of these. Even though we have an hour and a half, I still would not have enough time to adequately discuss each one of these tools and utilities. And also on June 20th, Ted Andreni's team is going to be doing a pretty extensive program on iTree Hydro, so we might just mention that one briefly today. But I'll probably focus more so on the assessment tools and the online tools and some of the aerial assessment tools, but I will mention some of the utilities. So it's going to be a bit like drinking from a fire hose going through the next phase, but good news about drinking from a fire hose is that you still are able to quench your thirst. So we'll try to get through these and see if you can stick with me on this. So I'm going to talk a little bit, just briefly touch on 2 of the utilities. And we have some management utilities, iTree Species and iTree Storm. These are basically complementary tools to urban forest management. I don't really consider them assessment tools, but they can be helpful. And so the species selector tool is part of the installation package. And I like to view this tool as an aid in selecting trees. I don't really get a whole lot of questions on this from users or feedback. And so essentially what this works on is basically the parameters where you put in your location, height constraints, and then you select what are those functions that you're most interested in, and then it'll return a list based on those parameters and hardiness zone of what might be those trees that will provide those services, those functions that you're most interested in. So the thing with this tool, which I always try to remind people and why I call it complementary, is that it does not have the logic to take into consideration local knowledge and local values in terms of what is invasive, soil conditions, and so forth. So it's just a different way of looking at tree selection, but certainly it doesn't mean if iTree says Norway maple is the most tree in terms of providing energy reduction, which it may be because that tree has a very dense canopy, but Norway maple is probably invasive to many folks. And so things like that, you have to kind of rely on that local knowledge and just use this as a complementary tool. So that's iTree Species. iTree Storm, which was formerly the Storm Damage Assessment Protocol developed by some folks at UMass, and it has since later been upgraded by Francisco Escabeta and some other folks who were helping him to develop a hurricane adaptation. This here again is another complementary urban forest management program which is part of the suite. And so the idea with this tool is to provide a simple and efficient methodology to assess widespread storm damage immediately after an event. So the purpose of this tool is to be able to provide timely information for management in terms of what are the resources needed for dealing with debris cleanup, tree pruning, hazard removal, and so on. So here again, this tool was first developed in the Northeast, primarily for ice damage. I don't get a lot of feedback on this one from folks, and there are some other people. I know Rich Hauer at UW Stevens Point was looking at doing something new. Eric Kuehler from the Forest Service has been working on trying to adapt iTree Eco to use some of the biomass information and the plot information to try to come up with some more different ways of developing another storm damage assessment protocol. So we don't get a lot of feedback on this tool too, and it still is part of the package, and we do support this. But this is also, here again, just considered a management utility. And I will mention iTree Hydro in case folks aren't able to participate in the next webinar later on in June with Ted Andreni's team. And iTree Hydro is probably one of our newest and also a tool that takes iTree into a different direction. It is essentially a tool that it's a sophisticated model, and it's designed to simulate the effects of tree cover change and impervious cover change on hourly stream flow and water quality within a watershed. So it's a watershed modeling tool, and it needs a number of different data variables, so hourly stream flow, hourly weather, and then you need a digital elevation of a watershed. And the application will walk you through all the steps that's needed to acquire that, but it does take some background and understanding, a little bit about hydrology modeling, and so that's one of the things that's challenging for our team too. We don't have that skill set necessarily in our team, and we rely a lot on Ted and his colleagues at Syracuse to kind of help us learn a little bit more and understand some of the nuances of this model. And one of our developers is currently working on the next version of this, and hopefully within, I would think the next, I saw some recent demonstrations and it looks like it's coming along well. So right now this is at version 4.0. It's essentially the same as what it was in version 4, but version 4.5 should have some, I believe, some snow melt routines and also a lot more in terms of improvement in the user functionality and user friendliness of the tool. So I don't want to dive too much in this because I know that we're going to dedicate a lot of time to this later on in June. But that's iTree Hydro, and that's also part of the version 5 package. So let me transition to what we're going to spend the bulk of the day talking about next. So we'll start out with the field tools. I'll start with streets, eco, and we'll see how I'm doing with time. And I may skip over some of past, so I might bounce around a bit, so bear with me. So iTree Streets. This is a tool that was developed by Greg McPherson's team at University of California, Davis, also part of the Forest Service. And it is a tool that is designed for assessing trees in the right-of-way. So hence the name iTree Streets. And it is based on research that was conducted in reference cities, and I'll talk a little bit about that. But the idea here again was that you can use that structural information, tree species, DBH, and then be able to determine functional values for those trees. Energy conservation, stormwater interception, carbon sequestration, aesthetic values, monetary values, and then also some management information. One of the other nice features about this tool is that it also provides cost-benefit information. So the idea with this is that it was really designed for folks who are managing municipal tree resources. And most often those people will have information on the inputs. So what are the costs of pruning, removals, employee wages, and so forth. And in the end, they could then look at what are the benefits being provided by those trees and see what is the dollar value that they're getting in return for that investment. So some of that information is quite powerful, and we'll take a look at that. And the pest detection module is an optional feature which can be used on this program too. And so there are a number of different ways of using iTree Streets. You can do a complete assessment, and that would be taking information on all street trees. But if you don't have enough time, there's also a protocol that allows you to do a sample assessment, so based on random street segments. So you would then go to those street segments and then basically catch or collect information on the trees within the right-of-way, put that into the tool, and then it would extrapolate up an estimate. And so a lot of people would say, well, what good does that do? And for a lot of folks, you just don't have the resources that are available to do a full-blown inventory assessment of an area. And so I know a lot of communities within 3 days or so, working with a number of volunteers, are able to go out and collect this information really fast, and it gives them some baseline data. They might then be able to use that to advocate for a more comprehensive assessment in the future. So it really kind of depends on the resources that you have available, but everybody might not be able to have what they would like initially, and this just gives you another option. And as I mentioned, this is based on reference city research. So this, I like to refer to it as a regional tree model. And so essentially what happened here is that the folks in the Forest Service went to 16 different cities and conducted the research to really develop a predictive model that allows a user then, so it's really simplified in terms of the user interface, because essentially the model will predict what is the canopy, the leaf surface area, and so forth, the functional benefits based on a given size of a tree, species that you select in a region. So the inputs are rather small for this because all that research has gone on in the back end to allow it to make it rather simple for folks to use. And this is just a map showing the location of those reference cities. That's the term that we use here. So when you're using this tool, let's say like in the Midwest here, I'm in Chicago, I'm basically saying that my trees are similar in growth characteristics, and the management characteristics that went on in Minneapolis would be somewhat similar here. But I can make some adjustments to this model too. So you can fine-tune this also. So you can put in some local values. So these will have defaults all set up for you, but you can then go in here and put in local electricity, natural gas information, and then update the home resale value too. So you have a couple options here to fine-tune this. Some of these other areas here are a little bit harder to find information on, and so most folks will accept some of these values in terms of pollution, carbon, stormwater information. And this is the type of information in the end that you receive back from iTree Streets. So here again, looking at the cost benefit for every dollar spent in the city of Elgin here, they're receiving back over $4 in ecosystem service benefits for those trees, energy savings, stormwater information, air quality improvement, and then also just some structural information here, and then this is the carbon information. So it's really compelling. And the thing I also like about these tools is that it gives you good information for understanding these ecosystem services, but it also provides a lot of very good information that helps urban forest managers. So you can look at things like the species composition of trees and what are the, the risks. So for this particular city, what is the green ash here would be something I would be concerned about. That's probably going to be phased out over time. There are also more interesting reports, such as this is one of my favorite, the relative age distribution. So this one here is what we're looking at here. This graphic is kind of showing us our tree species, and then also you can see the DBH of those species. So it's using a DBH kind of as a measure of age here. So a lot of times what you'll see is that a tree like silver maple that has kind of fallen out of favor, but now it's one of the more larger trees in that population. And so it's providing a lot of functional benefits, but it's probably not being planted anymore. And then so you can see back here what is being planted. So usually, this is what we're seeing. Our urban forests will transition sometimes from these trees that are in the forefront, bur oak, silver maple, Norway maple, to these trees in the background. So, flowering crab, little leaf linden, and so forth. And so what I tend to see when I look at this graph is that folks are transitioning to smaller scale species. So you're making a decision whether you're conscious of it or not to have an urban forest that might be providing less ecosystem services in the future. So seeing this is kind of a powerful tool in helping you maybe adjust your management strategy. And so, yeah, here again, this might be the obvious that larger trees do provide more benefits, but now we can actually quantify it on a city or an area basis. So, in this particular case, the bur oaks of Elgin were providing about $120 a year in benefits compared to the smaller stature trees. So we have that information. And this is another nice chart that's available in iTree Streets where it's looking at importance. So it's not just based on the quantity of trees, but it's using a mean of 3 relative values. So the percent of the total trees, the percent of the total leaf area, and the percent of the total canopy. So you can see a tree like silver maple here, although there's about 3,500, it's the second most in terms of importance because of its size in terms of leaf area in that structure. And so that's a lot of data there to look at, and this is just a more simple way of kind of presenting that information. So it's just a quick way of, kind of transitioning and looking at that resource and the importance of canopy, which drives functional benefits. So one of the new features with Streets and Eco is the introduction of this mobile web-based collection system that we have. And this was just introduced in October of last year, actually. And so this is actually our first full field season of having this available for folks who are interested in doing an assessment. And if you weren't familiar with iTree, if you were using one of the assessment tools, the field-based assessment tools, you were pretty much either restricted to using paper or PDAs, which worked off a Windows Mobile operating system. And both of those are still available and supported because there are actually a lot of people that have devices that still run on that old Windows Mobile operating system. But there was that demand. When are you guys going to develop something for an iPhone? When are you going to develop something for an Android? And so on and so on. And with limited resources, what we kind of eventually decided to do was to develop this mobile web form system. So this is not an app, so it's not something that gets loaded onto a mobile device. What this is, it relies on internet connectivity and a device's browser. So you do need to access the internet. And how this works is that you still would have a project manager developing a project on a desktop. He would then send a data link to whoever he wants to do data collection. So you just create a data link, and then you could send that to any number of folks, and they would be able to then access through a website on their browser, and it would look like this essentially. And so you would just populate information on that browser screen. So you're filling out a web form. So I use that term a little bit more than app because it's not necessarily an app. So with that comes a little bit of danger in terms of if you close out a web form, think of it anyway. If you're filling out a form on an internet site, you could lose data. So there's not a way to save data like you had in the old system where you can save it to an SD card and so forth. One of the nice things is that newer smartphones have caching ability. So that helps overcome some of the issues where if you lose internet connectivity. So what you're seeing there is my Android device. And even if I lose internet connectivity, once I have that active, I'm still allowed to continuously connect data because it's a newer web browser and a newer phone. And then once I regain connectivity, I can then submit that data back to a server where the project manager can then retrieve that to populate the desktop. So it's just a matter of moving through these forms, and then once you're ready, you submit that data to the server, and then the person that's managing the project would then retrieve that. So another nice thing about this, and this is kind of just something that somewhat of an unintended consequence, is that I still am a fan of paper for a lot of reasons, and one just for the simplicity of not having to introduce technology to folks too, and also for not having to buy devices and needing internet connectivity and so forth. So we heard recently from somebody who was using paper with a number of people collecting data. They would then just go back to their desktops wherever they were working and then enter that using the mobile web form on a desktop. So it was just another way of using it, not in the field, but now allowing multiple people to enter data and submit that back to a project manager. Whereas before, folks who are familiar with iTree, if you were collecting data on a PDA, required you to travel back to the mothership, then dock that PDA and so forth. So it's just another way we didn't really think of, but it's allowing for different dynamics in terms of data collection. So that is the mobile web form. This is also available with Eco too. And so that's Streets. And here again, It can be done in a complete inventory mode. You can do it sample. One of the most popular ways of using iTree Streets is for folks who have data to actually import that information in. So it requires some formatting, but then you can then look at that resource and the ecosystem services of trees in a community. And we took a look at some of those graphs and charts, and it's just a tool that allows you to be a little bit more effective in terms of management and advocacy. So that is streets. And I think what I will do is jump into Eco and try to get through this one, and then we'll take a break. So iTree Eco, here you can see that this also provides a number of the same type of functional information. It too provides numerous amounts of structural data. It has things like importance values and so forth. I think there's probably about maybe 35 different charts, tables, and there's actually a canned written report that's available in iTree Eco too. So it's fairly extensive. There are a couple new things that have been added in version 5. So this avoided runoff component is the first of availability that we've had in terms of providing some stormwater type information. It's a little bit different than streets. It's not just considering interception, it's taking into consideration some of the information that iTree Hydro does. So it's looking at things like the impacts of water depression and so forth, and that not all canopy intercepted rainfall is necessarily held, and so the values in iTree Eco for avoided runoff tend to be more conservative than what you'll see in iTree Streets. Another report which is really neat is we've added a public health impacts report, and I'll show you that in a little bit. There's more information now with pest risks and exotics, and it also too provides information in terms of monetary values for some of these ecosystem services. So the original idea behind iTree Eco was it was mostly intended for city managers or county managers, but it really is adaptable to multiple scales. So we see folks now who are using this in small city parks all the way up to statewide assessments. But originally, the only way that we had that you could use it when this was called the Urban Forest Effects Model, or U4, was it would be a sample type based project. So you would generate, typically it was about 200 or so points, and then you would then have to travel to those random points to sample the vegetation in those plots. And then so this is a 1/10 acre, so it's roughly about a 37-foot radius. And so you would have to find that plot center and then collect information on the vegetation within that plot. And so in some cases you might end up in the middle of the woods, or in other cases you might have to sweet talk your way onto private property. And so you could end up in somebody's backyard essentially too. And so you would establish plot center, collect a number of variables about trees. So it's not just species and condition and DBH, but you also have to provide this model with tree height, crown width, crown dieback, how much is exposed to light. So there are a number of data variables that are involved with this. You're basically giving the model almost a 3D picture of that canopy, and so it's fairly robust. It's not just making assumptions in terms of the size and missing components of a canopy. You're defining that in the metrics that you supply. In some cases, if that tree is within proximity to a building and you wanted to find out the energy effects, you would then have to take a distance measurement and provide the coordinates. So in this particular model, both the proximity and the orientation of a tree matters, so you can't actually have a negative energy impact. So the data variables that are needed in iTree Eco are quite a bit more extensive than what is needed in iTree Streets. But it's a very robust model because it uses local weather, local pollution information, and then your local tree data to do hourly simulations. So you don't have that problem where if you're in western North Carolina and you are kind of led to use the Midwest values for climate zone, you might have a little bit of a hesitation, whereas this one here you're allowed to pick the most available weather and pollution data to do your assessment. And so you do get a fairly robust assessment with iTree Eco, but yes, it is data intensive. And one of the nicer things with iTree Eco is that we've also introduced this option where we didn't have this before. This was just something new that came in version 4 that allowed folks who had a resource such as like a city park, well, I'm not really interested in doing a sample. I have a couple hundred trees and I'd like to get an assessment of that, but iTree Streets really isn't applicable. So this allowed them to then just enter in the tree variables, so you don't need all the plot information. And then you can still get structural information, carbon information, pollution mitigation, energy effects, stormwater, and some of the human health impacts. And you also now have the capability of importing in data. So what we're seeing here is a lot of folks, especially consultants, who are going out and doing inventories, such as something in a park, corporate campus, college campuses. They'll go out and collect that information that is critical for them in terms of managing the resource, but then they'll also import that data that is needed in iTree Eco. So they'll collect a tree height, tree width, and so forth with their inventory data, then import that into iTree Eco so that they can also get the ecosystem service information on that resource. So it's a nice way where I always look at Eco and Streets as being complementary to inventories, and that's just kind of a way how that describes that relationship there. So a couple updates. Eco has had a number of really nice advances, and I mentioned human health impacts, and I'll show you a little bit of that in terms of the report. Runoff modeling, web-based data collection, as we talked about, this is also available in Eco. Pollution model has been updated too, and we have introduced a mechanism to allow folks to generate those random plots from within the application. This was another one of those barriers to using iTree Eco as well. Now I need Esri GIS to generate plots, and so they're constantly changing that software. Our developers had to constantly rewrite the programs and instructions to how to do that process. And now with Google, I mean, we can really just define a shape either manually or using a shape file and generate those plots right within the application. So it simplified some of the barriers that we used to have to deal with. Pest detection and risk, that has also been expanded. And now pretty much Eco, it's the only tool that we have in terms of a field-based assessment tool that can be used internationally. So folks in Canada and Australia basically have the same functionality and accessibility to Eco that we do in the States. So there are some limitations in terms of things like the energy model. That really, they just don't have the background information and the research for us to have that work the same way, so they rely on some of the U.S. data for some of those estimates. And this is just an example of the human health impacts, which is something new and available in Eco. And this is based on an EPA BenMap model. And so this model is kind of designed to look at the impact of pollutant concentration reduction and how that affects public health. So, you know, we know from the iTree Eco model that we can model pollution mitigation too, but now coupling it with this BenMap model, we then can look at, well, what are those impacts in terms of public health? And so, for example, here, this is just some data from New York, and it's showing that based on what Canopy is doing in terms of removing particulate matter 2.5 or less microns, that is causing 4.5 less incidence of acute bronchitis, and there's a statistical value provided by the BenMap model of $398 per year for that particular health impact. So it's just another way of looking at how these impacts of what trees are doing to mitigate pollutants and how that actually we can now tie that in to human health. So we're kind of really excited, but this has just become available this year. So we're really just trying to, you know, see how this is providing value and learning from our user base, how it's being integrated with their management and policy objectives and so forth. And so here's an example of the expanded tree risk for insects and disease. And so this here at the bottom is just a number of known insects and diseases. And so Asian longhorn beetle, some of these are familiar, oak wilt, some of these aren't so familiar, and there is a key for these. And so this is showing the ranges of these pests in relationship to the risk of the resource. So for example, Asian longhorn beetle here, what we can see here is that these ones in red are within close proximity to a study area, and that decreases as it moves to green. And so the range is over here. So for 250 miles within a county, Asian longhorn beetle is fairly close to Baltimore. And so this is showing us both what are the number of trees at risk, so you can see it's pretty substantial, and then that compensatory value of that resource. So this was, this is something that I didn't know how well this would be received, but some of the people who have actually received this data, I was talking to a couple of urban forest managers in Michigan, and they said it's really valuable in terms of looking at their resource and what are those risks. And quite a bit of folks are still kind of worried about Asian longhorn beetle, emerald ash borer, gypsy moth, and so forth, and both newer disease in terms of things that affect like black walnut and so forth. So it's a nice way. It uses a database of, I believe it's from the Forest Health Technology Enterprise, to kind of get these range maps to provide just a simple snapshot of pest risk and disease to a resource. So that's iTree Eco, and here again, it's a very robust tool, multiple scales, local model, and it'll provide you some of the same information, but it is data intensive, labor intensive, but there are multiple options for doing this or using this tool. One of the things I wanted to do is just to kind of put these up side by side so you can kind of see, just a difference in some of the data requirements, keeping in mind that Streets is really a tool that is somewhat limited to working with right-of-way trees, whereas Eco really can be adapted just about to any particular resource that you might be interested in. So I think at this point here, I'll take a break and see if we have any questions that we can answer, Justin.
So there's two questions. One is a two-parter. The first one should be pretty easy. Does iTree support all 50 states?
Pretty much, and we even provide support to folks internationally too. So about a third of the people that we help are actually abroad. But yeah, it's we don't have. I must say I don't hear a lot from folks in certain states. You get a wide variability of people that use iTree all throughout the country. But yeah, we do.
Great. And then the next one is, this appears to be a very comprehensive suite of programs, exclamation point. Are there methods in place to engage citizen scientists, for instance, the master naturalist organizations? And then the second part is there a comprehensive list of adopters?
Well, there are some pretty comprehensive manuals that were set up to walk you through the various phases of going about planning and executing a program. So it will walk you through that. And so you do have that capability of taking that information and working with most levels. And keep in mind, if you're working with iTree Eco, it's going to have a greater requirement of skill and labor. So a lot of times, I was talking with somebody from Newark, New Jersey, and they told me that the type of volunteers and their skill sets that they were interested in working in and what they were interested in looking at. And that might steer you to a certain tool. But yeah, I would start with the manuals. The other thing too, which is really nice about these tools, is since it's free, if you can load it on a computer, you then can also look at sample projects that are embedded in these programs. So you can run the reports, look at the data that was entered, play with it to see what's required. And I'm also a fan of pilot projects. So there again, that's another way of starting out small, seeing what's involved with entering data and collecting data, and then building upon that too. So that's another way of using this. What was the second part of that question, Justin? I'm sorry.
Oh, if there's a comprehensive list of adopters.
I wouldn't say comprehensive, and that's somewhat challenging because the software can be downloaded. So we know who is registered and download software. That does not necessarily mean that they have used the software or what tools they have used or how they're using it. So we pretty much know who's downloaded it, where it's being downloaded, and so forth, but we don't have a good grasp on who's actually using it and how, other than some of the information that comes back when we intersect with users if they're having problems or if they have questions or they want to pass on reports to share. And what I tend to do is I also advise folks to talk to your state coordinator, because a lot of times they have a better grasp on what are those projects that are being carried out locally or within the state, and oftentimes they're the people who are helping fund those projects too. So they might even have a better grasp of who's using iTree and how it's being used. So we might have some partial information at best on that.
Okay. A couple more questions popped up. So Kent was wondering if there's a cost associated with any of the programs.
Well, the software is free, so the cost would be in terms of the labor involved with executing the project. So that can vary depending on if you're using in-house labor, you can use consultants, you can use volunteers. So it can literally be all over the map depending on the scope and so forth. Both Streets and Eco were kind of designed to allow two people to collect data within a typical city, either it be 200 plots or 3 to 6% random street segments for a typical city within a summer. So that was kind of one of the parameters when the folks who conceived these models tried to make it somewhat doable that you can actually achieve these within a season. But yeah, I've seen people complete street assessments with 40 different volunteers from colleges within a week. And then it takes some time after that to crunch all the numbers, but it's hard to say exactly what it's going to cost. On the iTree website, we do have some information under resources archives that some of the folks at Urban Forest South have put together, which will kind of give you some ideas in terms of like how long it might take and some of the elements involved in planning an eco project. So that might be a resource that I would suggest you can kind of consult if you're interested in that.
The next one is, how exportable is the data from iTree Streets? Is it GIS compatible? Our town uses maps online. I'm wondering if we could migrate data to there.
You can export the information from Streets. They're not designed to be fully integrated with GIS. So you can export that information out, and then you would have to import that into a GIS or another system. But it's not fully integrated, so if you make changes or manipulate the data into GIS, it doesn't have a seamless transition to move it back to Streets for updating. So there again, it kind of goes back to the way I see people using iTree Streets as a complementary tool. So a lot of folks might have their inventory in a GIS or another system and then periodically export that out and then import that into iTree Streets just to do the benefit assessment, say every 5 years or 7 years or whatever they determine as part of their own management objectives. So you can, but it really doesn't, it's not a seamless transition back and forth.
So I'm going to do probably 2 or 3 more, and then we'll move on, and anything we don't answer, maybe we can hit on at the end.
Sounds good.
So this one asked, carbon dioxide, monetary value per pound seemed on the low side. What are the assumptions behind the figure selected for that?
Well, for iTree Eco, that has been updated, and I think we're using some new methodology. I don't want to dive into all that information right now. There is quite a bit. What I'm going to try to do, though, is I will show you, if I can slide this over, hopefully you can see that. Under Resources Archives, if you're interested in any one of these models, all the methodology, background, papers that we have available can be found here. And so there's a number of journal articles that talk about a lot of these, and some of the information is somewhat old in iTree Streets. iTree Eco is a little bit more dynamic, but this is where we kind of keep all that information stored. So we have this here for Eco, we have it for Streets also. There's community tree guides that explain some of the background assumptions and information and how those are derived.
Does iTree work only on a Windows-based computer? Do I need other software to run iTree?
Yeah, and here again, system requirements can be found on the website too. So I will show you where that is. But it is a Windows-based software program, and you can load it on a Mac if you have one of those programs that allows you to dual boot and run a Windows-based program within that environment. That's something that we don't support, but yeah, we do have some folks who actually run iTree within a Mac environment, or on a Mac within a Windows environment, I should say.
And then this will be the last one for right now. So please expand on exotic versus native species usage. Would that impact the outcome in the model?
There is a new report in iTree Eco that just will look at the species that are exotic to a given area. So that's something that is it's new, and then it's also, it looks at exotic and native in terms of nation. So a lot of species, there's a report that's available that will show you the country of origin. So for certain species that maybe they're here, that might be in the States, but they originated in, say, Europe or Australia or Asia, you'll just see a breakdown of those species that ties back to a database that is within the background information of iTree Eco.
Great. Thanks, Al.
All right. Well, I think what I'm going to do here, Justin, is I'm going to bounce past detection and move into some of the online tools. And if we have time at the end, I can come back to pest detection, because I think we'll probably be a little bit tight on time here. So what I want to do now is kind of transition to some of the tools which are more new than the gateway tools, but I think really provide some great opportunities in terms of accessibility, and just what I use the term gateway. Anybody who's ever heard me do an iTree presentation, I like to call these gateway tools, because they can be used very fast and they can give you some really good information, and they might be used as a foundation to build a case to then do an iTree Eco or iTree Streets project. So the first tool is iTree Canopy, and this is an online tool. So it's an online web-based tool, and the nice thing about this one here, going back to somebody's question, is you don't have to install the software. You can access this right through the website. It's just a matter of going to applications and hitting iTree Canopy. And so this tool is designed for those folks who are interested in trying to determine the canopy cover of an area. So it is really a photo interpretation tool, and it is based on defining an area. And so what the tool actually does is it just generates random points within that defined area. You decide what it is that the cover types that you're interested in surveying, and it will do the statistical estimates in the background and provide you with a cover estimate. So it's proven to be fairly accurate, and it's actually one of our most popular tools right now. So I'll kind of just move through this, and it's very simple, and you can kind of see how it actually works. So the first thing you would have to do is define an area. And initially, when this tool was first made available, you had to provide a shapefile, so you had to have that, there again, that background ArcGIS as a shapefile. In a more recent versions, you now can actually draw in your own boundary. So maybe you're just interested in your own neighborhood within your city. You can actually just draw that in and create your own survey for an area of interest. If you have the shapefile, that's certainly helpful, especially if you are interested in a complex boundary. It's good if you can have that shapefile. If you're interested in an area, most city departments have access to that type of information. Some folks at the state level might be able to help you get that too. But you have a couple options of using that to get that shapefile. And there are also free programs like QGIS, which folks can use too if you really are having problems going through any other avenue. And here again, what this is you decide what it is you want to survey. And in the default, you'll see tree and non-tree. So if you were just interested in determining what is a tree cover canopy for an area, you might just only have something this simple. Other folks might decide, hey, I want to know what is the impervious surface for roads, buildings, grass, shrub, whatever that may be. You can make it as sophisticated as you like. Generally, you see folks maybe surveying about 5 or 6 different cover types. So here's just an example of what you would go through. You would just add in another cover class. This one's just showing water here. And so now we have 3 cover classes for this little demo. And then you're ready to start assessing points. So it's very simple. So load a shape or create a shape, decide what it is you want to survey, and then you begin the survey. And so what you'll see is this little dialog box, and then you hit the plus, and it generates a random point somewhere on that map, somewhere within the boundary. So in this particular case, you would then have to go to the drop down, and it happens to be in water. You'd select water and then move on. And then so here you're doing the surveying, and so it's non-tree. If we had impervious road, it would be that selection. And then you just go on through the survey. And so it's just a matter, after a while, it probably takes about 3 hours or so to move through about 500 points. And usually 500 points, what you'll see is that this is after 500 points here. So it's kind of keeping a running tab of the estimates. So it's doing the statistical estimates in the background based on the survey that you're doing. And you'll see those bars actually shrink. So here it's telling you that tree cover canopy after 500 points is 26.2, a little less than plus or minus 2 on that value. So the more points you do, the tighter the accuracy of the estimate is going to be. And generally, between 500 and 1,000 points, it kind of depends on the variation of the vegetation within an area. Certainly, if you're doing a smaller area, you might see that, within a couple hundred points or even less, you might have that statistical standard error might be acceptable. But typically for a city, I'd say I do about 500 points, and I'm pretty satisfied with that standard error. But that's up to the user, and also just sometimes the variation of the vegetation might kind of determine how fast that changes. Up at the top, if you want to go in and look at the background information, how those calculations are being performed, you can actually run a quick report. So this is just something that you'll see from this. It's very simplified, so it's somewhat vanilla, but it gives you that standard error estimate and also the estimate of those cover types. So it's a nice simple tool just for quickly determining canopy cover. And so yeah, there are a number of different ways of doing that, sophisticated UTC studies and so forth. iTree Eco actually provides that too. But this is something that you can do right from your desktop with a little bit of time and some effort. And so how are other folks using this? And here again, going into some of the implementation strategies. Wisconsin DNR, Kim Miller from Wisconsin DNR has used that along with iTree Street. So when they were doing a street tree assessment, they also looked at what are those canopy cover estimates. And this was the scheme that they used for their cover types. And what they decided to do is consider these potential urban tree canopy. And so this is just their own determination, and some people might not agree with this. Maybe some folks might say, well, I wouldn't consider agriculture as potential, but for their project they decided these are the parameters that they wanted to use. And it's really fantastic information. And they have about 17 different communities that they have now using the same type information. Another way of using this too is if you have multiple areas within a town. So here are 7 different wards. Now there's really no way of doing something easy like this. So you essentially would have to do surveys in each one of these wards and then compare them. And so a lot of people say, well, can't you guys develop something to overcome that? And simple answer is no. You pretty much are somewhat confined to doing each one of these wards. But the information that you get back, though, is really valuable for allowing you to be strategic in terms of if you have limited resources for planting, or if you're looking at developing new parks or open areas or whatever that may be. It gives you some real valuable information as to how you can make those decisions more strategically. So I think it's, and the other thing too, when I see projects like this, is I think it also provides opportunities to engage those people in those communities, whether it be school groups or so forth, to do those individual surveys and bring them together. And, you know, hey, why is our ward not doing as good as Ward 5? And so it's you can have ownership of some of this data by actually turning it over to people within the community. So there's a lot of different ways that you can use these tools, and since they're online, you don't have the barriers of installation and so forth. You can share data. So if I started a Canopy project, I can email it to somebody else and they can continue on with it if they wanted to, and email it to somebody else and so forth. So you can kind of work as a team too. There's just another example of one of my colleagues, Jason Henning, recently did a small urban park outside the Philadelphia area, Arboretum. And so just looking at that shape of the Arboretum and doing a quick assessment and seeing that it has 63% tree canopy, then shifting that same shape over and doing another assessment with the same amount of points in the adjacent neighborhood, showing that it has 17%. So it's just a way of showing the impact of having that, you know, resource nearby in a heavily urban area. So just another way of, you know, somebody showing how this tool can be adapted rather easily, just to kind of show the impact of a Canopy resource. One of the other things that you can do with iTree Canopy now also is a change analysis. So on the left here, if you go through the process of doing a survey, there is a function that allows you to export out those points as a KML or I believe KML or KMZ file. You can then bring that into Google Earth and look at those same points. And in Google Earth, you have the ability to actually go back and look at historical images. So here, this one's going back to 2005. You can then see what that was and if it's changed. So you can do another analysis. You can update this information with the 2005 image and then have basically a change analysis. Where have I gone? One thing to be aware of that I've tried this, and even just going back to 2005, a lot of the images are really grainy and they're not, in terms of the resolution isn't as crisp. So it's a little bit challenging if you're going to do this, but it can be done. So that's just another way that Canopy can be used, and it probably might be of more value. A lot of folks say, well, we're worried about the impacts of emerald ash borer and things like that. And so that would be something where if you had a Canopy assessment and you know emerald ash borer is coming, you have that baseline information, and then you can monitor how that has impacted your community over time. So that's iTree Canopy. I'm going to now jump into another tool, iTree View. So iTree View is another aerial-based assessment tool that's available within iTree, and probably one of the lesser used tools too. But I really like this tool, and especially when you combine it with iTree Canopy, and I'll show you how I do that too. One of the things that Canopy works, or I should say View works with, is National Land Cover Dataset imagery. So this is free imagery that's available from a government website. And so you can see here it's showing you a couple different types of imagery that you would get. So this is canopy cover, impervious, and just land cover. And so I'll show you how that works. And it combines this imagery, runs it through an interface, combines with some of the background information that the Forest Service has and the iTree interface, and allows you to get quick canopy cover information, but then also some crude, or I should say coarse, ecosystem service estimates based on state averages that we have available. So here's how this works. You basically go to this website. It's a multi-resolution land characteristics consortium, MRLC, and it's kind of just, if you've ever used a county website where you can kind of look at parcels, it works somewhat in the same way, where you just zoom into an area of interest, create a box around that area of interest, and then you can download those 3 NLCD images. And so these are the 3 images, the 3 raw images that you would get, and then you would load those into the view interface. So what you're seeing here is the view interface. You would browse to those locations where you downloaded those files, and you would then select some information where you're doing your assessment. You actually now, one of the problems with view, and I'll talk a little bit about the image issues, but one of the problems that folks have is that, well, I'm restricted to just looking at a rectangle that I can download. But so unless you went through GIS and actually modified those images, which you can do too, but within the interface now we've developed a tool that allows you to go out and carve out an area of interest too. So you might have that rectangle of that area of interest, but maybe you're only interested in looking at a college campus or a smaller area within that, whether it's your city or not. You can actually go into view without the use of GIS and make some modifications to that shape so that now we can just run the assessment here of that area of interest. So you can see here it's showing us that there's 12% tree canopy in this particular little section, which I believe is a campus area, the impervious cover. It's then showing you some of the tree cover and impervious cover characteristics within the NLCD land classes. So I won't go into too much detail on these, but one of the other limitations with iTree View and why folks kind of tend to shy away from using this is that, well, the images are very coarse, as you can see. So this is 30-meter resolution that it's using. And let me just bump up. So you're not going to capture all the canopy that may be in an area, especially when you're working in urban areas. It might not capture some of those individual trees that you might see in a really robust, high-resolution UTC type study. So there's an underestimation that we know is involved when you're using these NLCD images. And so one of the new advances in view is that the Forest Service, Dave Nowak and Eric Greenfield from the Northern Research Station, then went back to look at, well, what is that underestimation in each one of these regions, and can we use that to refine those view estimates? So they basically use the same methodology that photo interpretation that iTree Canopy uses to determine what are those underestimations, and so that you can now adjust that underestimation if you're using iTree View. And so I'll kind of show you how I use this combined here. So this is an area north of Milwaukee. This is the city of Mequon, Wisconsin, kind of tabled in here. And these are the 3 raw images, land cover, canopy, and impervious, that I would receive from the MRLC website. So I could then bring those into View, use those same tools that I showed you to actually carve out the area of interest for that city. So this was done without GIS, just basically looking at a map and kind of carving out the boundary, and then poking in this donut hole, which is actually another town, Thiensville, within the area. So now I'm only looking at my area of interest. And it showed me that there's 19% tree canopy, 8% impervious cover. I know that that is being underestimated. So I can go in and within the application look at that information on the underestimation for that region. So this is region 50. I'm roughly around here, and it's showing me that that underestimation was about 11.4 in terms of that canopy value. So I could then add that onto that 19%. But this is looking at an underestimation over a very large region. So if I happen to use iTree Canopy, and here's how these tools working together coupled, I now have a more local value of my canopy, which I feel pretty good about the accuracy of that estimate, plus or minus 2. So I can use this estimate and plug this here into view instead as the adjustment. And so it's a little bit small, but you can see the canopy cover. I now bump that up to 32.2%, and then have view run the estimates on that. And so here's my 32% canopy cover. I bumped up my impervious cover, and what it does is it provides you with some estimates on carbon sequestration, carbon storage, and then also pollution mitigation here too. So again, these are coarse estimates. It's not taking into consideration that ground element that you would have in eco. What are the stem diameters and so forth? It's just using some state averages. But in really about less than a day, you can literally have canopy cover, impervious cover, and some coarse estimates. So for those who may not have the ability to go out there and do field work, it's just a way of getting your foot into the door in terms of trying to get some simple information. And there again, without the use of GIS too. So that is one of the ways where you can use view, canopy for simple implementation. The last tool I wanted to talk about is iTree Design. And this is actually one of my favorite tools. And here again, this is another online tool, so it's accessible to anybody. You don't have to load software onto your system. It's for parcel level analysis. It was first only for individual trees, but now it's been expanded out to be used on multiple trees. We've also added, you may have heard us talk about iTree Forecast before. This is actually the only tool that has that ability integrated into it, so you can actually forecast out benefits into the future. And so it's a tool that's really designed for schools and homeowners in general. So it's something, if folks are familiar with the National Tree Benefit Calculator, which was a very simple online tool and still very popular, this kind of just builds upon that platform. And what you're seeing here is a tree basically looking out my front window, and it's a tree that we lost. It's an elm tree. And so I like to use this tool just to look at what was the value. Sometimes you don't realize the value of a tree until it's gone, those impacts, like I said. And so this is something that you can go into iTree View, and there are just simple steps that require you to trace select the tree from a drop-down, and it's based on the region. You put in some parameters, the tree size, tree condition, when the house was built, and you only have 3 choices here because that affects the energy effects, and then you place the tree. And it gives you some estimates of those ecosystem services. So in some cases, you'll see that this particular tree, 36-inch American elm, it's gone now, but it was doing quite a bit in terms of stormwater interception and providing summer cooling. And I can attest to that since that tree is gone. My house is a lot warmer now in the summers. And you can go through and thumb through and look at the impacts sometimes. Here again, it might not be the dollar value that you might be interested, but it's showing you, the gallons intercepted by that tree in terms of stormwater, energy conservation information, and heating conservation information. And since it's using a dynamic model, it is quite possible that you might have a negative energy value because the proximity and the location or the orientation of that tree matters in this model. Air pollution mitigation information, you'll see this word avoided in some of these estimates. And so this is kind of tying back to iTree Streets, where it is using some of the information that's saying, hey, because there's an energy impact, it's reducing demand needed for a power plant to provide power, and so therefore there's less emissions and less pollutants. And so you see what we like to call this avoided impact. And you'll also see that in the carbon estimates too. So it's showing you annual sequestration, but then it's also showing you the impacts of energy production, avoiding carbon emissions by providing shade and so forth to the structure. So it's just a simple tool that provides you with a quick snapshot of those ecosystem services of a tree in relationship to a parcel. As I mentioned, one of the new features, you now can model multiple trees. So here again, it's the same steps, but you see some newer elements here. You can add in your trees, and then you also have, this is what the future forecasting looks like, where you can put a point in time. So 15 years out in the future, same type system setup. This is actually going through some changes right now, so it's going to be a little bit different in the future. But then you can look at those estimates there again. So we can see what are the overall estimates of those combined trees or the individual trees. And you see here to the left there is this tab for future years. So we can also look at the benefits projected out. What are those trees going to provide in terms of benefits 15 years out? And so this is a tool that has been adopted by Arbor Day Foundation, working with a number of utilities to promote energy conservation. So here again, certain communities, and I'm not sure, I know the number in the southeast, Nebraska, have kind of started this program where you can go on here, working with the local utility, agree to plant a tree strategically. The utility will pay for it. Arbor Day provides the tree, and it's just a great program to not only improve the understanding of energy efficiency, but also to help people get trees in the ground strategically. Other ways that this can be used is if you're interested in modeling tree planting. So say, here's 8 trees that are being put in the median. You can go in iTree design and really rather quickly just pop all 8 trees down here. We don't need energy effect information because this is just in a median. And I've just, put in some typical figures for a 2.5-inch diameter tree that might be planted out there. And you could look at those ecosystem services, both now at the current year, which is really kind of minor, and then also in 25 years to see what is that impact. And then also here again, it might not necessarily be the dollars, but what are those impacts in terms of, say, gallons of stormwater intercepted from current year to 25 year. That might be the thing that people might say, hey, wow, this is great that we're planting these trees, but maybe there's some impetus now to manage these trees so that we can actually receive these benefits when these trees are mature. So again, just a nice way of using that tool to help advocate for management or grant writing or things like that. This is just a mock-up of, one of the things that we don't have that limitation if you go back is that we can show you current year and then future year, but what are those cumulative benefits over time? And that's something that we're working on. And so we actually do have that capability to provide that. And this is just a mock-up of, we're trying to work out, how to do that, the calculations that get involved. I'll doing that on a website. But this will be pretty exciting too, because not only will we be able to look at current year, future year, but what are those impacts over time? And so this should be coming out hopefully sometime soon. We've been kind of testing this, and it works really nicely, and I'm excited that this is kind of the direction that this tool is moving toward. Another thing that really has been exciting too is seeing what other folks are doing with this. And so I've seen nurseries use this to promote tree planting, where they allow folks to access iTree design, and then so it's just a way of showing the value of trees in relationship to a parcel and how that might affect those things that people might not think about in terms of energy efficiency and so forth. But here Mary Van Dyke, who is an educator in Virginia, is also using this tool and doing a number of really neat things with this too. So in terms of providing education for middle schoolers, and so we've been in conversations with her, trying to figure out how can we help her advance some of these initiatives and try to keep the momentum going. But it's a great tool in terms if you have a newsletter, or if you're, I'm going to actually be working at an event this Saturday at a community where I will be at a booth and have iTree design set up where homeowners can come and just learn a little bit about the way that the trees in their own yard are providing ecosystem service benefits at a parcel basis. So that is iTree design. And I think that is pretty much where I'm going to wrap things up. And yeah, here again, I know this is kind of like drinking out of a fire hose. There's a lot of information thrown at you. And again, where did you start with this? I would say that the website is a great resource for information, but then again, even just installing the tools and poking around in the software and looking at the available projects that are embedded in there will give you kind of a good understanding of what are those reports, what are the data requirements, and so forth. The other thing I would say is a lot of people that I kind of cross paths with in time are waiting for perfection, thinking, if only you guys can make this available on a Mac, if only I had GIS skills, if only I had time. And there are a number of people who are finding really innovative ways to using these tools and developing partnerships and so forth, and working with universities to do some pretty cool things, nonprofit organizations. And that's where I really see people achieving some significant improvements in terms of their management and policies when they're able to kind of bring these other stakeholders to the table, which not only helps them get projects completed, but to effectively create change. So that is all I pretty much have. I think I will open it up back to Justin at this time for some questions.
Great, thanks, Al. That's a great overview. Definitely like drinking from a fire hose. That's awesome. So there's a couple questions. Let's see. First one is, has iTree been used in a rural setting or to analyze larger forest parcels, let's say greater than 200 acres?
It has been. I know there are some folks who did some, mostly students that I recall, who have done some assessments in Washington State, and Eric Wiseman from Virginia Tech has done some smaller scale assessments recently in some areas outside or within actually the I think the campus areas, and so yeah, it can be used. iTree Eco can, but it can be very intensive in terms of the data collection that's involved once you get into those areas. So folks might actually use smaller plots in those cases, and that helps, or they might use less plots too, because there's not that much variation in the vegetation as to when you get into more urbanized areas. But yeah, they have been used, but not to that great extent, because our primary audience is people that are working in urban settings. But yeah, you do have some instances where you end up in the woods collecting data oftentimes. In iTree Streets, is one of the data sets latitude and longitude, and is it possible to use a smartphone's ability to generate lat and longs in the web form for data entry? Yeah, iTree Streets, if you have a device, like my phone has GPS capability on there, it will work with iTree Streets. So it's really dependent on that device's accuracy, and it can be hit or miss. Sometimes it seems to be pretty dead on. Other times, depending on topography and so forth, it could be 10, 15, 20 feet out from where I was actually standing. But if you do have a device that has GPS capability, that can be accessed, and you can collect that information while you're collecting that data out in the field too. It hasn't been integrated in iTree Eco just because that tends to work more with plots, but probably that will be something that we'll have to work towards in the future to integrate in Eco. But right now it's available in Streets.
Great. And then the last question is, how large an area is iTree Canopy designed to be used?
It can be really adapted just about any area. If you recall where I said that Eric Greenfield and Dave Nowak used that in those regions, which are pretty much the same size as a state, and they did 1,000 points within those eco regions or those regions within the NLCD classes. So it can be used on multiple scales, and you will see, as you go through that progression, that the standard error will then decrease the more points you do. But it can be used on large scale assessments too.
Perfect. I think that was the last question on the list. So thank you so much, Al, for taking the time to speak with us today. And thank you, everyone, for attending. As a reminder, I did record the session, so I'm going to post a link probably on the Vermont webpage, but I'll also just send it out through an email to everyone that RSVP'd. Al alluded to this, but also wanted to let folks know that we're going to be doing a follow-up webinar in June focused on iTree Hydro and how that is being used to model green infrastructure. So look for more information from that. If you RSVP, I will certainly send that out to you. And I think that's it for today. So again, thank you everyone, and have a great day.